For our next topic with the trigonometric identities, we look at the idea of the cofunction identities. These identities come directly from the meanings of the cofunctions. The meanings of the cofunctions is that the cosine is the sine of the complementary angle. That's where the co comes from, the complementary angle. So given an angle of theta, the sine will be equal to the cosine of the complement. And we know we find complements by just taking in degrees 90 minus the angle, in radians pi over 2 minus the angle. So we get that the sine of theta is cosine of pi over 2 minus theta. Likewise, cosine is the sine of pi over 2 minus theta. So tangent and cotangent are linked, and we have the tangent of theta is cotangent pi over 2 minus theta. Cotangent is tangent of pi minus 2 over theta. And likewise with the secant and cosecant. The next type of function of identity is the odd and even identities. Now these, it's very helpful to picture the graphs of sine, cosine, and tangent to know just how these work. So the first one, the sine of the opposite of theta, is equal to the opposite of sine of theta. So if we look at the graph of sine here, we see that if we put in a value of pi over 2, which would give us this point right here, and we take the sine of the opposite of that, the sine of the opposite of pi over 2 would be over here. It gives us the opposite value. Here we have a y value on the right of 1, and on the left a y value of negative 1. Recall earlier we talked about the idea of odd and even functions. And here we see then that the sine is an odd function. That is, it's symmetric through the origin. Since sine is an odd function and cosecant is its reciprocal, that means cosecant will be an odd function also. So cosecant of negative theta is negative cosecant of theta. With the sine, or cosine, sorry, we have the graph right here, and we see that that graph is symmetric about the y-axis. So that tells us that is an even function, and when we take the cosine of a negative angle, we'll get that's the same as the cosine of the positive angle. Likewise with secant, secant of negative theta is secant of theta. Tangent, we see again the graph here, or one section of the graph anyway, and tangent is an odd function. It's symmetric through the origin, so the tangent of negative theta is equal to the negative tangent of theta. Now that kind of makes sense if you think of the idea of tangent being sine over cosine. So we have an odd function, sine, over an even function, cosine, gives us an odd function in tangent, and likewise with cotangent. We can use these identities in working with things like find the sine of x minus pi over 2 if the cosine of x is known. So we see that that x minus pi over 2 isn't quite what we want. We really want the pi over 2 minus x. Well, we can fix that problem by factoring out a negative 1. So we have the sine of the negative, or the opposite of, pi over 2 minus x. Well, two things happening there. We have the sine of a negative. Because sine is an odd function, we know that is the negative sine, using the odd-even identities. And then using the cofunction identity, we see that the sine of pi over 2 minus x is the same as the cosine of, and that should be an x there instead of a theta, the cosine of x from the cofunction identity. But the cosine of x, we're told here, is negative 0.75. So we have the opposite of negative 0.75, which is 0.75. Now I'll try to apply those ideas to this problem. Pause the video while you work it out, and then check for the answer. And there it is. We have that a is negative 0.73.